Hello students, Professor Barber here. This lesson is titled Quadratic Functions and Their Models. Quadratic functions are a special class of polynomial functions and they're of degree 2. Their graphs are a parabola. Upon successful completion of this lesson, you will be able to 1. Obtain quadratic functions in standard form. 2. Be able to graph quadratic functions from standard form. 3. Be able to locate and identify maximum and minimum values of quadratic functions. And finally, 4. Be able to solve applications involving quadratic functions. Roman numeral 1, Polynomial Functions. This lesson begins our study of polynomial and rational functions. We start with quadratic functions and their models. We have discussed the following common or standard functions. The constant function f of x equals a. The constant function has the graph of a horizontal line. The linear function f of x equals ax plus b. You should recognize this form as f of x equals mx plus b, and the graph of a linear function is just a line somewhere in the coordinate axis. Okay? The square function f of x equals x squared. That's the graph of a parabola through the origin. And we're going to expand on this for the quadratic functions, and we've even looked at cubic functions. That's f of x equals x cubed, and its general shape is increasing through the third quadrant, go through the origin, and then up through into the first quadrant. The above functions are types of polynomial functions. Continuing with a formal definition, a polynomial function of degree n is a function of the form p of x equals a subscript n, x to the power of n, plus a subscript n minus 1, x to the power of n minus 1, plus ... plus a subscript 1 x plus a subscript 0, where n is a non-negative integer and a sub n does not equal 0. All these subscripts and superscripts can be a little bit intimidating. Just remember, when you're looking at a polynomial function, say p of x, the a sub n is some number, 7. X to the n has to be a positive whole number, and so it could be to the 8th minus 16 x to the 4th plus the square root of 4, oh, that's a whole number, but that's okay. How about square root of 4 pi x squared plus x plus some number, and I'll just give me a number, 25, okay? So the 25 would correspond to the a sub naught, that's the constant, and the numbers like 7, negative 16, square root of 4 times pi, and even the one that's not seen but multiplied to the x, those are your coefficients. Roman numeral 2, quadratic functions. A quadratic function is a special type or another type of a polynomial function. Formal definition: a quadratic function is a polynomial of degree 2. So a quadratic function is a function of the form f of x equals a x squared plus bx plus c, where a cannot equal 0. If a equals 0, then the x squared goes away. You end up with a linear function. Let's continue. Definition: a quadratic function f of x equals ax squared plus bx plus c can be expressed in standard form, which looks like f of x equals a times the quantity x minus h squared plus k by completing the square. The graph of f is a parabola. In standard form, we express the parabola as f of x equals a times x minus h quantity squared plus k. The vertex from the standard form is the ordered pair hk, and it explains or reveals the most extreme point of the graph. The axis of symmetry is x equals h. Notice that it's a vertical line. It is a vertical line that goes through the vertex. It is an axis of symmetry because on either side the shape of the graph is identical. If a is a positive number, then the graph opens upwards and the vertex, as you can see, is a minimum. If a, the leading coefficient, is negative, then the parabola opens downwards and the vertex is a maximum. Consider the function f of x equals 2x squared minus 16x plus 31. Part A, express f in standard form. In standard form, we're going to have to complete the square, and so for the function f of x, remember the leading coefficient has to be 1. So I am going to factor 2 out of the first two terms. That would give us 2, and then x squared minus 8x, some space, plus 31. To complete the square means to make a perfect square. So we've got to figure out what number to add next to the 8x that would give us a perfect square. Remember, whatever you add, you must also subtract to maintain the balance. And in this particular instance, you're multiplying by a factor of 2, so we have to remember that when you're subtracting, you also multiply by a factor of 2. In order to find the number that goes in the blank, okay, my suggestion is that you first identify the linear coefficient. That's a fancy way of saying the number that's multiplied to the x, and in this instance that's negative 8. The second step then is to half it. So half of negative 8 would be negative 4, and finally square the half term. So negative 4 times negative 4 is positive 16. We're going to add 16 and we're going to subtract 16. That's multiplied by a factor of negative 2. Let's clean this up a little bit, and so we'll get 2 times our perfect square. X squared minus 8x plus 16 can be factored into x minus 4 squared. And then we have the 31 minus 2 times 16 is 32. So in complete square or standard form, we would have that f of x is equal to the factor of 2 times x minus 4 squared minus 1. Part B, find the vertex and the x and y intercepts of f. In Part A, we computed the standard form, and that standard form was f of x equals 2 times x minus 4 quantity squared minus 1. Now, let's recall the generic standard form, which looked like a x minus h squared plus k. The vertex is defined as h comma k, so from our standard form, we glean that the vertex is 4 comma negative 1. Now we have to find the x-intercepts, and to find the x-intercepts, we're going to have to use the quadratic formula. The quadratic formula says that x is negative of b plus or minus the square root of b squared minus 4ac divided by 2a. So let's identify the parts. The negative of b is the negative of negative 16, so that's positive 16, plus or minus the square root of 16 squared minus 4 times 2 times 31, and all of that is divided by 2 times 2. Okay? Simplify that, keeping the radicals, and you'll get 8 plus or minus the square root of 2, all divided by 2. And that gives us roughly that gives us 2 values exactly. That tells us that 8 plus the square root of 2 over 2 and 8 minus the square root of 2 over 2 are the x-intercepts. Okay, so we have a vertex, which I'll mark as 4, -1. Okay, now we need to get the y-intercept, and the y-intercept is going to be way off the graph here because that's the constant, and that's 0, 31. So let's remember these values and continue. Part C, sketch the graph of f. We know that it's a parabola, so let's go ahead and check off that we know that it's a parabola. We also know its vertex, and that vertex was 4, -1. Now we're going to use a little trick of symmetry, and so I'll pick x, f of x, and I'm going to pick a number to the immediate or one less than, so I'm going to pick 3 and 5. So let's compute. If I compute 3 in the function, 2 times 3 squared minus 16 times 3 plus 31, the output is 1. And if I compute it with 5, that's 2 times 5 squared minus 16 times 5 plus 31, that's also 1. And that actually gives us enough information to get a pretty decent sketch. We mark the vertex, 4, -1, then 3, 1, 5, 1, and remember we have an axis of symmetry that goes through the vertex, so whatever the graph is doing, we know that it's going to have a minimum, go up. It looks like this, and I'll just mark up here somewhere as the y-intercept 0, 31. Okay, and now find the domain and range of f. The domain is the set of all acceptable x input values, and so the domain turns out to be all reals, -infinity to +infinity, and the range is the vertical expanse of where we see the graph. You can also get this value by looking at the vertex. It's upward facing, so the lowest y value is -1, and it increases indefinitely. Roman numeral 3, maximum and minimum values of quadratic functions. The vertex of a parabola can be obtained from the general form of a quadratic function, that is the form f of x equals ax squared plus bx plus c, by setting x equal to the negative of b divided by 2a and y computed as the function evaluated at the negative of b over 2a. You can do this without first having to complete the square. If a is positive, remember that means that the parabola opens upward, then the most extreme point of the graph is the minimum value, and it is denoted as f of h equals k. If a is negative, then the parabola is upside down, and so the most extreme point of the graph is the maximum value of the graph, and f of h equals k gives you that value. Find the maximum and minimum of each of the following quadratic functions. One option is to complete the square. The other is to use the vertex formula, which was negative of b divided by 2a, and f evaluated at the negative of b evaluated at 2a. So let's find the x place first. And so x is going to be equal to the negative of b is 3. Remember, b is the coefficient of the x term. Divided by 2 times a is -12. And so we're going to have negative over negative. We'll have -3 over -24. And that simplifies to +1/8. Now, that tells us where a particular value occurs. Now we need to find the actual function value, so f at +1/8. This will be 3 times 1/8 minus 12 times the quantity of 1/8 squared. This will give you 3/8 minus, oh good, 12 over 64. And with a common denominator, 3/8 can be written as 24 over 64 minus 12 over 64. And that'll give us, let's see, 12 over 64, and that reduces to 3/16. While all of this is primarily arithmetic, it's real important that we know what each of the numbers mean, okay? This negative tells you that the parabola is facing downwards. So we're going to have a max value of 3/16, and it occurs at x equals 1/8. Now let's continue to b. This one we've got to multiply through first so that we can pick out the a's and b's correctly. So let's distribute the 2x, and you get 2x squared minus 2 times 4 is 8x. And the 5 really has no effect on here, but let's go ahead and write the 5 so we keep the integrity of the equation. X is going to be equal to the negative of b. The b this time is -8, so we'll have the negative of -8 divided by 2 times a. Negative and negative gives us a positive 8. Oh, good. 8/4 gives us 2. Now we need to compute its function value, so g at 2. You can do it in whichever form you want. I'm going to do in the original, so 2 times 2 times 2 minus 4 plus 5. That gives me 4 times -2 plus 5. -8 plus 5 is -3. So let me tell you what you have. This is a positive number. If it's positive, then you know that the graph of the parabola opens upwards, and your most extreme point is a minimum. You get a minimum of -3 at x equals 2. The x gives you the location, the f of x gives you the function value. A soft drink vendor at a popular beach analyzes his sales records and finds that if he sells X cans of pop for people in Texas, that's what we call Cokes, in one day, his profit in dollars is given by P of X equals the negative of 0.001x squared plus 3x minus 1800. What is his maximum profit per day, and how many cans must he sell for the maximum profit? So let's recognize that we are looking at a parabola because it's a squared function, and furthermore the coefficient is negative. So we know that you have an upside down parabola, and that's real important when you're looking for max. Okay, so let's find the x value. That's the number of cans he has to sell each day. That's going to be the negative of b, 2 times a. So the negative of b is 3, divided by 2 times the negative of 0.001. The two negatives cancel. You get 3 over 0.002. And that turns out to be 1,500. So he has to sell 1,500 cans of Coke. Okay, that's how many he sells. And the maximum profit we compute by evaluating the profit function at 1,500. So we got negative 0.001, 1,500 squared, plus 3 times 1,500 minus 1,800, and that turns out to be 450. So his maximum profit per day possible is $450, and that happens when he sells 1,500 cans of Coke.